Welcome participant for the Stata Training module. It is 18th day. Today is 2nd April 2024, and we are going to discuss the panel ARDL complete process in today's session. I will let you know the step-by-step procedure, how to validate the panel ARDL and what are the particular steps which are required for panel ARDL estimations. So let me show you an article, a good article that is written on panel data analysis that will let you know the procedure basically required for the analysis of panel ARDL. So this is the title of the document. It is written by one of my colleagues in Department of Commerce, University of Gujarat. The title of the article is Sources of Financial Development and Their Impact on FDI Inflow, a panel data analysis of middle income economies. He has also shared the data set with me for this article. And this article is basically covered all the procedure of panel ARDL. This is the line graph, or this is the line chart. This is showing the trend line for FDI inflow in middle income countries. You can easily create this graph using Stata. Then this is basically the purpose of their study. This study is meant to explore the impact of two leading sources of financial development, the financial institution and financial market development on FDI inflow. So if we see the set of hypotheses, there is a significantly positive impact of financial institution development on FDI inflow. There is significantly positive impact of financial market development on FDI inflow. There is significantly positive impact of overall market development on FDI inflow. There is significantly negative relationship between inflation rate and FDI inflow. There is significantly positive relationship between trade openness and FDI inflow. And there is significantly positive relationship between economic growth and FDI inflow. So these are the set of hypotheses. And I would like to show you the methodology. They have used the data from 1980 to 2020. Basically, this is a 40 years data, and they have considered 53 middle income countries here. So 40 years data and 40 years data and 53 economies, middle income economies. So this is the basic consideration in panel ARDL that you need to comply, that your N should be greater than 25 and T should be greater than 25. Now, when it is confirmed, you need to consider the other considerations also. So what we need to do for applying the panel ARDL, this is the basic requirement they have found. And the second condition for confirmation of this model is the cross-sectional dependence. As I have already mentioned that I have met this condition because when we consider the cross-sectional dependence, always remember that there should be no cross-sectional dependence in your data. If no cross-sectional dependence is found in first generation, if no cross-sectional dependence is found, then you need to check the stationarity using the first generation test like IPS and LLC. So they have considered all these analysis procedure. This is a very good paper that you can apply. And for for the validity of panel ARDL, they have tested the stationarity and they found the dependent variable at level at first different or mixed effect. So if we see our results, we can also find out that dependent variable is stationary at level as well as at first difference, while the independent variable, these these variables, some of them are not stationary at level, but they are stationary at first difference, and some of these variable are stationary at level as well as stationary at first difference. So if you see here, DV is giving us an 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 analysis procedure here for stationary at level as well as at first difference. And IVs are giving us an impression of mixed stationarity. It means some of the variables are stationary at first difference, while some of the variable are stationary at level as well as at first difference. So they are giving us a perception or an overview of mixed stationarity. So in that case, you need to apply the panel ARDL. This is the reason, this is the justification that you need to follow here. So as a second step, you need to, as a first step, the first step for this purpose is consist of descriptive statistics, which are used to summarize the data of the study. So I have mentioned here that you need to run the descriptive statistic, then you need to run the correlation analysis. So I have mentioned here. So as a first step, you need to analyze the descriptive statistic for your study. I need to highlight it. The first step is descriptive statistics. And the second step is the Pearson correlation. The third step is to estimate the cross-sectional dependency. I have mentioned here the cross-sectional dependency. And always remember that if cross-sectional dependency is found, then there are other procedures that you need to follow here. But if cross-sectional dependency is not found here, then you need to go first generation unit root test like IPS and LLC. So fourth step is to estimate the panel unit root test. That is the first generation panel unit root test. The fifth step is to estimate the optimal length, optimal lag length of 53 middle income economies. So I have summarized here the optimal lag selection criteria. If you have a time series data of a specific country, the simple command is var SOC. This is the command which we use in time series data. But as we have a number of countries more than one, therefore we need to have a panel optimal lag selection criteria. So this is the code we are going to run as a loop. So I will let you know how to apply this code. So additionally, the sixth step requires the estimating the panel cointegration. This is the optional step. This is not the compulsory step. If you would like to consider the co-integration test, it is optional. So you may use XT Padroni test in order to check the co-integration in your panel. The next step is the final step is to estimate the panel ARDL using mean group MG, pooled mean group PMG, and dynamic fixed effect DFE. So this is the final step according to this criteria, but according to me, this is not the final criteria. You can also estimate the causality test as an optional test if you require, if you would like to see whether there is a two-way causal relationship exists between the variables or not. So you can also consider as a 10th step for the causality test. So in order to decide between mean group, pooled mean group, and dynamic fixed effect, we have to use Hausman specification test. So reason for choosing, there is a question, why we check co-integration and any particular reason? Basically, co-integration test help us to identify the long run relationship. If there is a co-integration between the variables, it means there is a long run relationship between the variables. So in order to identify the long run relationship, normally the researcher run this procedure as an additional or as an the optional procedure. Although we can also estimate the long run and short run procedure from the panel ARDL also. So we do not need to run this procedure. It is an optional procedure. So that is why I have written here optional. So if you feel that you should run this procedure, then you are going to run it. Otherwise, it is not compulsory. But the thing is, the reason is for running the co-integration test is to confirm the long run relationship between the variables of interest. For example, if I would like to see whether there is a long run impact of my IVs on my DV, then we need to check the co-integration test. But this is also confirmed from panel ARDL. So it is an optional procedure. Therefore, the most of the researcher run the panel ARDL and they do not include the co-integration. But if you would like to include, there is no basically limitation for not including this analysis procedure. So this is the basic model. First of all, they created a simple model based on FDI inflow, financial development, inflation rate, trade openness, and real growth rate. This is a simple model. This is the basic panel data model. Then to create the uniformity and normality in the data, the basic model was transformed into log model. So they included log term with every variable. If you see here, they have created the log term. So in order to create the uniformity between the variables of interest, they have created the log term. Then the model was transformed into panel data by adding IT as the subscript, where I refers to the cross section, means countries, and T refers to the time dimension. If you see here, they have included IT as a subscript with each term. So you will see IT with all of the terms here in the model. So this is a step-by-step procedure for a panel data model. Finally, they have converted it into panel ARDL. This is the journal panel ARDL model. If you see here, this is P, these are Q, 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 Q. So P stand for basically the dependent variable and QQ stand for independent variable. So these are basically the pattern of lag length in your model. Because if you see here, there are some DVs and IVs into your model. There are a set of independent variable. For example, in this case, 1, 2, 3, and 4. There are 4 independent variables, and there is a 1 dependent variable. That is why they have used a number of dependent and independent PPQQ. They have used 6Q. Maybe there were 6 independent variable there. So this is the panel ARDL structure. If you see this structure, It includes a lot of symbols here. They have elaborated symbolization here. What does mean by which symbol? This is the parameterized panel ARDL model. If you see here, there is a change or first difference terms here. So this is your dependent variable, and this is the t-1 dependent variable, and this is first difference dependent variable, and this is first difference independent variable. This is basically the structure of a panel ARDL model, because in panel ARDL model, you are going to run the long term as well as short term procedure for your panel ARDL, or for your independent variable effect on dependent variable. So this part, if you see the first part without this sum sign, so this part is relevant to your long run effect, while this part is relevant to your short term effect. So panel ARDL is the combination of short term as well as long term effect. Therefore, this is the structure of the model. So this is the descriptive statistic. If you see the mean, the standard deviation, kurtosis, skewness, minimum, maximum, they have included here. This is the correlation analysis they have included here. Then this is cross-sectional dependency. As we have discussed that no cross-sectional dependence is there, because this is the starting point for panel ARDL. Always remember that panel ARDL is applied when you do not found any cross-sectional dependence in the model. Then you need to test the first generation unit root test. So no cross-sectional dependence is found. Now they have tested first generation panel unit root test. This is at level, and this is at first difference. They have used LLC, IPS, and Breton. And if you see here, this is the dependent variable, and the dependent variable at level are not stationary. If you see here, their value, they are without steric sign. But at first difference, they are stationary. So what is the first requirement for applying the panel ARDL? The first requirement is that your first generation unit root test, if I would like to show you, your DV should be stationary at first difference. This is the first requirement. If it is stationary at level at as well as at first difference, you may consider it as a first difference. Then your IV should be stationary at mixed level. So if you see here, these are the IV, OFD, FID, FMD, inflation, TOP, RGR. So OFD is not stationary at level, and it is stationary at first difference. If you see here, these are stationary at first difference. If you see the next one is stationary at level, but according to this unit root test, this is not stationary. And in LLC and IPS, they are stationary, but weakly stationary. But in case of first difference, they are stationary. So in the same way, if you see the other variable, some of them are not stationary at level, but stationary at first difference. And some of them are stationary at level as well as at first difference. So this will create mixed stationary. So when your IVs are mixed stationary and your DV is stationary at first difference or at level, in that case, you are going to use panel ARDL. So this is how they have validated the panel ARDL. So this is how you can validate the panel ARDL. Here they have mentioned the stationarity of dependent variable at first difference, while the stationarity of independent variable at level and at first difference mean mix. Validate the application of panel ARDL method for the estimation of the hypothesis. Now, this is the justification why they are going to use the panel ARDL. So, as a next procedure, what they are going to do. Now, this is the optimal lag selection criteria. If you are using a time series analysis, uh, then you have one country and a number of years, then there is a simple command that you can run, that is var SOC. You need to put your set of variable if you consider that there is only one country. This is the command. Max lag. For example, I consider max lag would be 2. Now, repeated time values in a sample, because this is not the time series model. It is a panel model. That is why it is not considering it a time series. So this is the command that you use when you have a single country. But in our case, we have a lot of countries here. If we see here in our data set, how many countries are there? There are 19 countries. There are 19 countries, more than one. So what we need to do in order to find out the optimal lag, because this is the next step that you need to apply. We have cleared with this. We have cleared with this correlation analysis, cross-sectional dependence, and first generation unit root test. We have uh, cleared with this. Now, in order to find out the optimal lag selection when we have a number of countries, there is a loop which is developed by some researcher, and I have modified the basic loop. The basic loop was somewhat lengthy, and I have changed this loop with the inclusion of the time series optimal lag selection criteria. If you find out on the internet, I would like to show you. If you go to the internet for optimal lag for panel, optimal lag for panel ARDL, you will find a lot of options here. There is a one option here with Stata list here, and hopefully they have provided the loop. I would like to show you. Yes, this is the loop they have provided. This is the loop procedure. I will let you know. They have used ARDL method, but I have used basically the var SOC method. Var SOC command is used when we are going to run the optimal lag for time series data. So I have included this. So this will basically run the procedure. What is basically mean by loop? Because if you see here, I did not uh, combine this command into one row. The loop procedure requires that, because it is written by some programmer, you need to write this command in this way. So you need to understand how can I run this command. First of all, this is for val or for values. I is equal to, you need to put how many countries or companies in your data set are. If we see this data set, we have 19 countries here. So what I need to put here, I need to write here 1 divided by 19. All right. Then put a space and put a medium bracket here and then press enter. And 3 times space, then write var SOC, your dependent variable. For example, how many variable are here? If I see here FDI, FB, uncertainty, CF, SPG, GDP, GR, GDPPC, TROT, inflation rate, exchange rate, RGR. These are the set of variables here. So I need to put these variables here like this. Then I need to write here if bracket. Now I need to see which is the coding of my cross-sectional variable. If I see here, my cross-sectional variable here is ID. So I need to write ID here. So you need to write here ID, double equal sign, and then I in commas, bracket close, comma, let's lag 2. You can also place 3 here if you would like to. Then you need to press enter and then bracket close in the third row, medium bracket, like this. Now, always remember whenever you write this code, you need to put the small letters rather than the capital letter. So let's see whether this code runs here. You need to paste this code here and click enter. And they have considered, I have written large I. All right. So I need to place a small I here like this. All right. So let's copy it again and place it as a loop. Press enter. Invalid I. They are not validating I. So let's suppose I change this command with the already defined command here. So country is equal to I. I place these variable here in this loop because this is user written. This is written by some programmer. That is why we need to be very careful while putting this command. So I will share this with you so that you can apply yourself. You just need to copy this command and you need to paste and enter. Country not found. All right, we do not have country, we have ID instead. We have ID here. We need to place here ID. All right. Now again put this command here like this and enter. Now this is going to run. If you see on the right side, this is going to run. So what we need to do, we need to finalize. We need to finalize country-wise. This is the first country. What are the optimal lag length for your variable? So you need to find out one by one with each country. So according to this criteria, you will find out the optimal lag length of your variables here. So if you see here, for the set of variable, you will find the optimal lag length. Now, this is the criteria of finding for a complete set of variable, the optimal lag length. Now, how can we how can we find out that what is the optimal lag length? There are three criteria: AIC, HQIC, and SBIC. Always remember that most of the researchers base their decision on the basis of AIC. So according to AIC, if we see here, there is a steric sign in front of 3. So we see here that the optimal lag length here is 3. So we can place this decision on 3. Some of the others may be found by you can see here in this case the optimal lag length here is 2. The optimal lag length here is 3. So you need to place variable wise these results so that you can find out what is the optimal lag length by each country. This is the next step. So after finding out, this is the data of 53 countries. So we need to place what is the optimal length of FDI, what is the lag length of FD, then FI, then FM, then inflation, and so on. So what is the point here that you need to find out the optimal lag of one variable at a time. You need to exclude other variables from this loop, and you need to repeat the same loop for each one variable again and again. In the next time, you need to include here the second variable. Then in the next time, you need to include the third variable. You need to see here what is your third variable, that is uncertainty. So you need to put here uncertainty as a third variable for finding out their optimal lag. So how can you decide the optimal lag? You need to see what kind of, according to AIC, which number or which row is basically have the steric sign. If it is in front of 3, it means 3 is the optimal lag. If it is in front of 1, it means 1 is the optimal lag. If it is in front of 0, it means 0 is the optimal lag. So you need to place one by one, like in this case, the optimal lag is 2, the optimal lag is 3, and so on. You will find the optimal lag. So you need to apply this procedure on each of your variable. After that, the next thing is co-integration test, the 7th step. So this is the co-integration test. And in this paper, 2 tests are basically used for co-integration. So you need to apply the Padroni test. If it is significant, it means there is co-integration in your model. I have included the interpretation here. The null hypothesis is there is no co-integration. And if your t-value is greater than 1.96, it means there is co-integration. There is co-integration. So if you see here, this is the p-value, and this p-value is greater than 1.96. So it means there is co-integration. So how can we run this model, or how can we check the co-integration? So this is the code for running this co-integration. So you need to write here xt Padroni, and you need to put here your set of variable. And always remember, this is basically workable with maximum 7 variables. So 1, 2, 3, 4, 5, 6, and this is 7. Because with more variable, it is not going to run the analysis. It is basically usable with the minimum variable set. So you can run this. No, not that. So there is a question. No, 6, 6. I think seven can be used. One, two, three, four, five, six, seven. I have run with seven. All right. If you see here, the p-value is greater than 1.96. So there is co-integration in this model. So this is the next thing. The next thing is decision about ARDL model because we have found mixed stationarity. So this is the criteria of running the model. So let me use this basic model here. Now we are going towards the panel ARDL. So what you need to do, you need to include here first difference dV. Then you include one by one first difference IV. You need to place here your set of IVs one by one. And you need to place here D dot, D dot, D dot, D dot, D dot, D dot, and D dot, D dot, and D dot. Then you need to place here first lag. This is L dot dV. And then you need to place here your IVs one by one. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, this is basically the long run effect. If you see the first part, the first difference part, this is the short run effect. LR stand for long run effect. And this is error correction term. And this is the mean group estimation. So you need to run this. They are requiring that we need to include the meta size. So set mat size 5000. So again, run this command and always remember that you need to make it in the one row. So it will show you the estimation of mean group. It will take some time. Meanwhile, you need to see the other command. The other command is the same. You need to place, you only need to change this one in the end, and then you run the Hosman test using this command, Hosman mg comma, sigma more. If the p-value is less than 5%, mg is suitable. Otherwise, we need to verify the PMG with BFE. The next procedure, if your mg is not significant, you need to run the same command, but at the end you need to place DFE, and then you need to run the same command, and then you need to place the PMG and run the Hosman test. If the p-value is less than 5%, DFE is suitable. Otherwise, PMG is suitable. Now, whichever model is finalized using this procedure, you need to put it as a final model. And then you can run the causality test as the time is less than 1 minute. So if you have any question, you can ask for this procedure. Yes, Wakar, do you have any question? All right, no question here. So this is the command which is run. This is the long run estimate, and these are short run estimates.